Hi, I'm Colin Devey. I'm a marine geologist, and with me is Marilia Urlaub, who's an expert on seafloor landslides. Now, we know that tsunamis are generated in the ocean. I guess most of us would think they're to do with earthquakes, but some of them to do with landslides. Why is that the case, and why are they so dangerous?
So it's similar to earthquakes. In submarine landslides displace a huge amount of mass and thereby bring the water into action, so to say. Mm-hmm. And they are particularly dangerous because these landslides can occur anywhere where the seafloor is inclined, so even on very gentle slopes. Mm-hmm. And they are pretty much unpredictable. We don't know when they occur, we don't know where they occur, and this makes us pretty much completely unprepared for these disasters.
Okay, and will every landslide produce a tsunami, or is there some way of differentiating?
No, because the tsunamigenic potential of a landslide depends on its initial acceleration, it depends on the volume of the landslide, and on the water depth in which the landslide occurs.
Okay, does that mean then that deeper ones are more dangerous, or is it the shallow ones that are more dangerous?
It's the other way around. So the shallower they occur, generally, the more dangerous they are.
Okay, and can we predict where landslides are going to happen? Do we have any idea to sort of say, okay, this is a place we want to be careful of?
Well, we can go to our geological inventory of the past, so we can look where landslides have occurred in geological times. But the factors that cause these landslides are very little understood. So we are just currently trying to understand the mechanisms that lead to seafloor failure, and this is particularly interesting because these landslides are not only much larger than any landslides on land, but they also occur on very gentle slopes, as I said before. So they occur on slope angles of 1 or 2 degrees, which is about that of a FIFA certified football pitch, and you wouldn't even notice that.
Wow.
That there is a slope.
Wow.
So, and these slopes fail catastrophically.
Okay, and is there something geological? Are there particular geological settings where you would say, okay, that's something you need to be careful of?
We don't have particular sites because, as I said, they can occur anywhere where the slope is inclined. We have made some progress in getting to know where very large landslides tend to occur and where rather small landslides tend to occur. So, interestingly, on active margins, so near subduction zones, we observe rather small landslides, but many of them. And on passive continental margins, so where you don't have many earthquakes, these landslides tend to be extremely big. So one example is this Dorega slide of Norway. So that occurred around 8,150 years ago, and the landslide moved a volume of debris that would cover the whole New York metropolitan area in about 200 meters of debris.
Wow.
So that's the scale we're talking about.
Okay. And is there any relationship to climate change? I mean, if we see sea level rise, if we see warming of the seawater, is that going to affect how landslides work in any way?
That's quite a difficult question because we are not very certain about the courses of these landslides. So what we can say is sea level rise as such does not affect the stability of slopes, but of course anything that goes with a sea level rise. So all the changes, the differences in sedimentation rates, for example, or similar things. So gas hydrates, for example, they make the sediment more stable, so they provide stability, but once they dissociate, this stability is likely to get lost. So we are not entirely sure what happens when these gas hydrates dissociate and the stability gets lost. And also earthquakes can trigger submarine landslides, and a rise in sea level is likely to increase the seismicity. So there could be a relationship with that.
Yeah, and when we're talking about earthquakes, we have something for measuring earthquakes in front of us, I believe, right?
Yeah, so this is an ocean bottom seismometer. We call it OBS. They think to the seafloor and stand at the seafloor for long times and for maybe a year or so, up to a year, and they measure the seismic activity. So they are basically a seismometer as we use them on land, but for use at the seafloor.
Okay, and with big orange parts on it, this is the flotation, so they come back up. You don't just throw them over the side. You do actually want to get them back
No,
again,
we do
right?
want to recollect them because we want, of course, to get the data.
Yeah.
And yes, so this is for flotation, and there's an acoustic release that is basically a little hook which attaches this thing to an anchor, and this can be released with an acoustic signal so that all of this comes up and the anchor stays.
Thank you, Morelia. Lots of things
You're
I didn't
welcome.
know about landslides and how they could probably generate tsunamis. Very interesting. Thank you.
Thank you.